The thing about crude oil is it's crude. Even if you could get that stuff into your petrol tank and somehow set fire to it, it wouldn't provide the instant explosive power that internal combustion craves. To be honest, you'd be better off coating your driveway with it than driving with it. To become usable fuel, it has to be refined.
So at the heart of the refinery lies the laboratory, headed by Joyce Bussey. It's up to Joyce's lab to supervise the process of turning the crude oil into usable products.
Crude oil in this state is not very useful at all. If you put this in your tank, you'd be sorry because it wouldn't go anywhere.
The trouble with crude oil is it contains a mix of hydrocarbons, each of which has a different number of carbon atoms. The hydrocarbons are different in weight. The lightest is propane, while the heaviest is used to make asphalt. Extracting petrol from this mix is a formidable challenge, and it requires one heck of a chemistry set to do it. The most important part of the plant is this. Like a moonshine still as tall as a cathedral, this is where the crude is separated. Heated to over 370 degrees Celsius, it's pumped into the base of the tower, and like steam from a kettle, the vapor rises. As it cools, the molecules condense. They're heavy asphalt and tar at the bottom, while lighter molecules, including diesel, jet fuel and petrol, continue rising until they too condense and can be siphoned off. But the trouble with producing all this fuel is they now have an ocean of potentially explosive liquid to deal with. But of course, it's this explosive quality that makes petrol so useful. So to make sure it's as explosive as it should be, it's up to workers like Derek Smalley to carefully take samples for analysis in the lab. In all, every 159-litre barrel of crude produces 73 litres of petrol, 35 litres of diesel, around 20 litres of jet fuel and heavy fuel oil, almost 6 litres of propane, and another 34 litres of other products, such as butane, asphalt and sulphur. Every day, this plant produces enough petrol to fuel a car on 770 round trips to the moon. Unless, of course, you drive a 4x4, in which case you may have to fill up halfway. Anyway, Derek delivers his samples to the lab for testing.
Our lab does the final product check of all product that goes out of the refinery. And if it doesn't meet our customer's expectation, it doesn't go out the gate.
The fuel is tested by feeding it to a petrol connoisseur, an aging but robust knock testing engine. Engine knocking happens when fuel spontaneously ignites as it's being compressed in the engine cylinder. The reason for this premature ignition is there's too much heptane and not enough octane in the mix. By increasing the percentage of octane, the mix can be improved until the knocking stops. The lab can then feed their data back into the main refinery to correct any mixing errors and ensure a perfect blend. With the refinery's work done, some of her 500,000 valves are opened, and the petrol flows through underground pipelines, which feed it to various local terminals like this one in South Houston. From here it's transferred to huge tankers for delivery by drivers like Bradley Unruh. But filling up a tanker is way more dangerous than simply filling up your car.
It can be dangerous, but just being a good, cautious, alert driver really helps.
The hundreds of litres of volatile cargo mean it's essential Bradley follows stringent safety procedures. A mistake while loading or unloading the tank could result in a serious explosion, so he takes no chances. The metal bodywork can generate sparks from static electricity, so first a cord is attached to ground the trailer, and also activate the overfill protection probes at the top of each compartment. To cope with the threat of highly flammable vapours escaping, a second pipe, known as the vapour recovery pipe, siphons off any leaks, which might otherwise escape into the atmosphere. Only once these are in place can Bradley connect the fuel lines and begin to pump. Every day, over 4 million litres of petrol are safely transported to local gas stations from this terminal alone. Pumped into the service station's huge reservoir, the petrol is finally ready for use. So you can at least find solace in the extraordinary work it's taken to keep your wheels turning the next time you fill up your car and grimace at the cost of your fuel.
But until your futuristic, flower-powered flying car comes along, you just have to grin and bear it. Coming up,